Hello friends, in this part of the video for differentiation 1, we will be discussing the topic of derivatives from first principle. Till now we have discussed a lot about left hand derivative, right hand derivative. However, as we have discussed, there are functions like polynomials and sin x cos x which are always differentiable, and hence we do not need to worry about LHD and RHD. LHD and RHD are generally equal unless specified at some points, like we have seen in examples. So rather than always trying to calculate the limits, there are already available very well documented formulas for calculating derivatives of various functions. In this part, we will learn how to derive those functions very quickly. We will see just very quick few examples, and give some few examples for homework, and then we will basically directly go into the formulas. So this is just a part for you to understand. This is something which probably won't really use a lot to for J questions. However, I think it is still valuable to learn and understand how to do that. For instance, we have been asked to find the derivative for all x, not just at one point, derivative for all x for fx is equal to x square. Okay, so we know that x square is a function which is a polynomial, and hence it is differentiable for all points. So we do not need to really worry about LHD and RHD. We can just directly write the derivative. So in general, and let's say that y is equal to fx. So dy by dx, the way we define a derivative, dy by dx, rate of change in y with respect to change in x, is defined as limit h tends to 0 f of x plus h minus f of x by h. Okay, so in this case, if we substitute the values, we will get limit h tends to 0 x plus h whole square minus x square by h. Now if we directly substitute h is equal to 0, we will get a form 0 by 0 form, because x square minus x square is approaching 0 by approaching 0. However, as we have already discussed in limits and continuity many times, that this is a form which you can factorize very quickly. If you factorize this form, you will get, this is nothing but h into 2x plus h using a square minus b square type formula by h, and here h gets cancelled and this becomes limit h tends to 0 2x plus h, and this is equal to 2x. Hence you are able to solve for the value of the derivative of x square for all x is nothing but 2x. So if I have to evaluate at x is equal to 0, there the value is 2x is 0. If I have to evaluate the derivative at x is equal to 1, this is 2 into 1, which is 2. So you can do that for all the different type of function, just directly use formula like this, and this is known as finding derivatives from first principle. So this is basically derivatives from first principle. However, in some time we will not actually be always deriving these results, and we will directly use the results which are very well tabulated in literature. So let us solve another problem for finding the derivative, and here fx is equal to e raised power of x. So we know that in other words y is equal to e raised power of x. So if you want to find dy by dx, we write dy by dx is limit h tends to 0 f of x plus h minus f of x by h. So we know that f of x is e raised power of x, so we can write it quickly, e raised power of x plus h minus e raised power of x by h. Now I have already discussed a very similar problem in limits and continuity chapter, that whenever you see something like this, we will try to make it a standard form. So because I am able to you can very quickly spot, I mean this is something which will only come by practice. I hope you can quickly spot that this is nothing but this, and we have discussed that this limit is actually 1. So this means that you can just remove this and this will become e raised power of x. So derivative of e raised power of x is nothing but e raised power of x, which is the same. So dy by dx of e raised power of x is e raised power of x, and as I said that this is nothing but 1, because we have discussed this in limits and continuity. So if you are forgetting these things, please revise the chapter, because that is important for calculating these limits. Just For your homework, I will recommend you to practice functions like sin x and cos x. They are again very easy to solve. One of the things that you might need to revise for functions like these is the chapter of trigonometry, because you will be using formulas like sin a minus sin b, cos a minus cos b. So if you have forgotten that, just very quickly recall those formulas and then start solving derivatives from first principle. So I hope you liked the video. This was just a brief example for derivatives from first principle. In the next video, we will start talking about formulas, which are very, very handy and very important for this chapter. Thank you.